This is Mr. Martin. These are video notes for section 8.3 for pre-calculus honors. By the end of this video, you should be able to solve problems involving geometric sequences and geometric series. So we've talked about sequences in general in section 1. We talked about arithmetic sequences in section 2. So for section 3, we're going to talk about geometric. A sequence is defined to be geometric if the ratios between consecutive terms are the same. So if you notice here, we have r, which we call the common ratio. With arithmetic, we called it the common difference. So if we take any term and divide it by the term before it, we will get this constant number called the common ratio. So a2 divided by a1 would be r, a3 divided by a2, or any term a sub n divided by the term before it, n minus 1, a sub n minus 1, is going to be that common ratio. So in a similar manner to what we did with arithmetic in defining the recursive formula, if I take r and I take this last term and I set them equal to each other, so I have the common ratio is equal to a sub n over a sub n minus 1, and go ahead and solve this for a sub n. I'm going to get this recursive formula. Again, you're going to want to define your first value, that's your seed value. So any term is going to be the common ratio times the term right before it. Alright, then we've got an explicit formula. So a sub n is going to be the first term times the common ratio n minus 1 times. Alright, and similar to what we did with arithmetic, we could also have another form of this would be a sub n is going to be a sub m times r to the n minus m. Okay, so to go from any term to any other term, you just have to multiply by the common ratio however many times it would take you to get there, which is the n minus m part. Okay, so this gives us a relationship between any two terms. This is how to find a term if we know the first term. So you may want to keep that one in mind as well. So our first example, we're given a formula for the nth term of some sequence, and we want to verify that it's geometric. So what we want to do here is let's look at the nth term. So a sub n is negative 3 times 1/2 to the n, and the a sub n minus 1 term is going to be negative 3 times 1/2 to the n minus 1 term, and if I divide these, I should get my common ratio, and these negative 3's are going to cancel, and if I have these fractions here, I can factor a half out of the top here, and I'll have a half times 1/2 to the n minus 1. Okay, this is just one way to simplify it. And then in the denominator, we would have a half times n minus 1. And then these two terms would cancel out, and I would get that this equals 1/2. Okay, so this is one way to kind of show for every case, or if we wanted to find a few terms, we could find the first term by plugging in 1. So I'd have negative 3 times 1/2 to the first, which is negative 3/2. And I could find the second term, which would be negative 3 times 1/2 to the second, which would be negative 3/4. Let's do one more. A sub 3 is going to be negative 3 times 1/2 to the third, which is negative 3/8. Alright, and then I can take a look and I can see what is a2 divided by a sub 1. That's going to be negative 3/4 divided by negative 1/2, which is 1/2. Or I could do a sub 3 divided by a sub 2, which is negative 3/8 divided by negative 3/4, which again is going to be a half. So we get this common ratio when we divide consecutive terms. And that's how we could show that it's geometric as well. Alright, so for example 2, we want to find a formula for the nth term of the following geometric sequence, and then we want to find the 10th term. So we know that the first term is 6, and we want to find the common ratio. So the common ratio is going to be either negative 2 divided by 6, or we could do 2/3 divided by negative 2. At either of these should give us the common ratio, which is negative 1/3. And once we have the first term and the common ratio, our formula, our explicit formula, is a sub n is equal to a sub 1 times r to the n minus 1. We'll substitute in what we know. First term is 6. Common ratio is negative 1/3 raised to the n minus 1. So this is going to be our nth term. That's like our formula for finding each term. And then I could substitute in 10 to find the 10th term. 6 times negative 1/3 to the 10 minus 1, or negative 2 over 6,561. Here's the 10th term. Alright, as usual, if you have questions, make sure that you write those down as we go along. Okay, so go ahead and pause the video and give this a try, and we'll take a look at this in class and make sure we got the same answer. Now let's move on to the sum of a finite geometric sequence. So here we have the terms of a geometric sequence. If we talk about the sum, this is our formula to find the sum of terms of a geometric sequence. Okay, and then the derivation, we'll look at this also in class when I see you, but if you want to give it a go, feel free. This is kind of a complicated formula. Just make sure that you memorize it. We've got the first term times 1 minus r to the n, all divided by 1 minus r. Again, a sub 1 is the first term. R to the n, or r is the common ratio, and n is however many terms we're adding up. So we'll derive that in class, so you can go ahead and leave that blank, but let's give it a try and see how this works. So we want to find the sum of 2 to the n minus 1 as n goes from 1 to 7. And we want to do this without a calculator. So if we look at the series, really what we're looking at, we're going to plug in the numbers 1 through 7 to figure out what these terms are and then add those up. But we don't need to, because we have s sub n is equal to a sub 1 times 1 minus r to the n, all divided by 1 minus r. And we know that the first term, a sub 1, is going to be found by plugging 1 in for n. So that's 2 to the 1 minus 1, which is 2 to the 0, or 1. So that's my first term. And my common ratio, so if I want to find the common ratio and we're not sure how to find it, just plug in 2, find the next term. So that's 2 to the 2 minus 1, which is 2 to the first, or 2. So that means that the common ratio is going to be a2 divided by a sub 1, which is 2 over 1, or 2. And then we need the number of terms, so n is going to be 7 minus 1, and then remember we add 1 back. We don't want the difference in the terms, we want how many terms we have. So we have to add 1 back, otherwise we'll have the difference and we'll be 1 short. So when you start at 1, it's really not a problem. This tells you what n is, so that's going to be 7. And then the sum of these 7 terms then is going to be the first term, which is 1, times 1 minus 2 to the 7th divided by 1 minus 2. And if we calculated that correctly, we should get 127. Okay, so when we talk about a geometric series, we're talking about the sum of the terms of an infinite geometric series, and it's called infinite geometric sequence, and it's called a geometric series. So we're adding up the terms of a sequence, we call it a series. So there's a couple different cases. We could have absolute value of r is greater than or equal to 1. Okay, and then we'll talk about the limit as the number of terms approaches infinity of the sum. So if r is greater than or equal to 1, that means that our terms are going to be either staying the same if it's 1 or increasing each time, at which case this sum is going to approach infinity as we add more and more terms. Okay, we call this divergent, okay, because the sum is going to keep increasing as we go to infinity. Or if the absolute value of r is less than 1, so we're looking at a fractional value less than 1, like a half or a third or negative a half or negative 2/5. So as n approaches infinity of this sum, we're going to get a value of a sub 1 over 1 minus r. Okay, so this is really a formula for finding the sum. Okay, so what this means is, and we've looked at this a little bit before, we can add an infinite number of terms and calculate an answer. Okay, that's kind of neat. Add up an infinite number of terms and actually get an answer. And we call this convergent. Okay, so you got to check your value of r. If it's greater than 1, you're not going to be able to get an answer if we add up an infinite number of terms. Or if it's the absolute value is less than 1, it will be convergent. So this brings us to the formula again. So we've got the sum of a sub 1 times r to the n minus 1. Remember, this just generates the terms in the sequence. As n goes from 1 to infinity, is going to be a sub 1 over 1 minus r. Okay, so this would be our formula. Alright, so let's look at an example. Determine whether each infinite geometric series converges or diverges. If it converges, find its sum. Okay, so we need to figure out what our value of r is. So r is going to be 1/3 divided by 1, or 1/3. Let's check the next ones. We would have 1/9 divided by 1/3, which would be 1/9 times 3 over 1, which is also 1/3. So my absolute value of r is less than 1, which tells me it's going to converge. Okay, so that means that my sum is going to be a sub 1 over 1 minus r. The first term is 1. My common ratio is 1/3, so that's 1 minus 1/3. So I get 1 over 2/3, which is 3/2. Okay, so if I add up every single term in this sequence, as n goes to infinity, we're going to end up with a sum of 3/2. Alright, so why don't you go ahead and try part B. And if you have, and we'll go over that in class, and again I'll answer any other questions that you have in class as well. And we'll see you next time.